We were considering the question whether the Jacobian matrix of a robot can have different rank in different configurations. Much before that, we derived an expression for the Jacobian, which is you are currently seeing here. So there are 4 columns, and they depend on the joint variables. That is the configuration of the robot. If the configuration change, the Jacobian also changes. Now, what we are looking at is when the configuration change, the Jacobian change, and when the Jacobian change to the rank of the Jacobian also change. That is the question we are considering. In order to answer that, what we are adopting is we are just showing 2 examples, 2 configurations. This is the one and this is the another one. This is the first, this is the second. The first is the standard configuration, which we have been considering quite a while. This is another configuration, and we evaluate the Jacobians for these 2 configurations, and these are the Jacobian matrices that we obtain. And again, using SymPy's library, we evaluate the column space of this matrix, which is here, and here also we evaluate column space of this matrix. Now we see that for the first Jacobian, the column space has only 3 column vectors, whereas for the second Jacobian, the column space has 4 column vectors. Therefore, the rank in the case of first matrix is 3, and the rank in the case of the second Jacobian matrix is 4. So based on whatever review of the rank that we did, we can say that the second configuration is having more maneuverability compared to the first one, because this has maneuverability dimension as 4, whereas this one has maneuverability dimension of 3. These things we have understood, but what we would want to know is there any relation between the rank of the Jacobian and the workspace? That is something we would want to explore here. Now, for generating the workspace of this robot, another video has been posted where the generation of the workspace has been explained. And now we will go back to the same app that was used in the video and see what relation we can have between the rank of the Jacobian and the workspace. The first configuration corresponding to which the Jacobian was evaluated is this configuration. So in this configuration, theta 1 is 0, theta 2 is pi by 2, theta 3 is minus pi by 2, theta 4 is of course inconsequential because the location of O4 does not depend on theta 4. Now let us see with respect to the workspace where is this O4 located. Let us put on the workspace. Okay, so this is the workspace, and this particular point O4 is at the the edge of the workspace. So definitely it is lying on the on the boundary of the workspace. Say you might recall that workspace is actually a volume. So the space from here to here is the entire volume that is considered as the workspace. So it is at the edge or it is at the boundary of the workspace. And we saw that for this configuration it had rank of 3. Now let us change the configuration. So in the second configuration, all the joint angles remain the same except the third joint angle. Instead of minus pi by 2, it should become 0. So let us just change it. I'll change theta 3 to 0. I'll bring it closer to 0. Okay. So as you might see, as I'm taking it to 0, this O4 is getting inside the boundary of the workspace. It is now no longer visible. It has gone inside. So yeah, let me bring it exactly at 0. Right, so theta 3 has been made as 0 here, and this O4 has gone inside the workspace. And if you are very keen, you can see that it has entered inside of the workspace boundary. It is somewhere inside. Uh, so at the outset, what we can say is for the configuration that was on the boundary of the workspace, the rank was less, and for the configuration that is inside the workspace, that is inside the boundary, then the rank was more. It was 4. For the boundary case, it was 3. For the inside of the workspace, it was 4.